Hello everyone, welcome to my video. In this video, I will explain about entity relationship. Before we discuss about what is entity relationship diagram, we need to know the three important components to build entity relationship diagram. First is entity set, and the second is attribute, and the third is relationship. Let's discuss in more detail. Let's start with an explanation regarding entity set. The entity set is an object that exists in the real world and that is different from the other object. Entity set have the attribute and as the builder of the system. For example, an employee who works for a company is called an entity. This entity has attributes which have a value. For example, each employee have employee ID. In addition, an employee has other attributes such as birth date, gender, address, telephone number, and so on. Next, we will discuss the second ERD component called attribute. Attributes are descriptions that describe an entity in more detail, such as department for employee entity. Entity has couple of attribute types. First is simple attribute. Simple attribute is attribute with a simple value, and this attribute cannot be decomposed into more specific attribute. For example, price attribute from a staff. The second is composite attribute. The composite attribute is attribute that can be divided into smaller attribute. For example, name attribute into first name, middle name, and then the last name. And the third attribute is single valued attribute. This attribute can contain only one value. For example, worker ID number or student ID number or gender. Each entity just has a value for this attribute. Next is multi-valued attribute. This attribute can contain 0, 1, or more than one value. For example, telephone number. It could be an employee has 0, 1, or more telephone number. Another example is hobby. Everyone can also have 0, 1, or more than one hobby. The last type of attribute is derivative attribute. This attribute can be derived from the other attribute. For example, in age attribute, its value can be derived from birth date by finding the difference between birth date and current date. This is the example of entity. For example, we have a student entity. This entity has attributes such as student ID, name, faculty, and department. Another example is an employee entity that has attributes such as employee ID, name, and department. The third component of ERD is relationship. Relationship explains the relation between the entities. In designing a database, an entity should have a relationship with another entity, at least with one entity. If there is an entity in the database that does not have a relationship with any other entity, then there will be error in this design. Usually, unrelated entity will be eliminated from the diagram. The example of relationship between two entities such as follow. Student entity and course entity have relationship take, so each student can take many courses. The other example is the relationship between lecturer and student. Every lecturer can teach many students. So this is the example of relationship. There are four kinds of relationship among entities. First is one-to-one, a second is one-to-many, and then many-to-one, and the last is many-to-many. Let's discuss these kinds of relationship one by one. The first is one-to-one relationship. In this relationship, Each entity in the entity set A related to the most with a single entity in the entity set B, and vice versa. Every entity in the entity set B is related most one entity in the entity set A. This picture shows you about one-to-one relationship. An example of one-to-one relationship is the relation about student entity and student card entity. Each student only has one student card, and one student card is only owned by one student. The second is one-to-many relationship. In this relationship, each entity in the entity set A relates with many entities in entity set B, but not vice versa, where each entity in the entity set B relates most with a single entity in the entity set A. This picture shows you about one-to-many relationship. An example of one-to-many relationship is the relation about lecturer entity and student entity. Each lecturer can teach many students in a class, but each student in a class is only taught by one lecturer. The next is many-to-one relationship. In this relationship, each entity in the entity set A related at most with one entity in the entity set B, but not vice versa. Each entity in the entity set B relates to many entities in the entity set A. This picture shows you about many-to-one relationship. An example of many-to-one relationship is the relationship about student entity and study program entity. There are many students in one study program, but a study program can contain many students. And the last is many-to-many relationship. In this relationship, each entity in the entity set A can relate with many entities in entity set B and vice versa, where each entity in the entity set B is related to many entities in the entity set A. This picture shows you about many-to-many relationship. An example of many-to-many relationship is the relation about student entity and course entity. Each student can take several courses and vice versa. Each course can be taken by many students. Next, I will discuss about the K. As explained before, entity set is an object that is different from the other objects. Each entity must have attributes that can distinguish it from the other object. K is one or more attributes that can uniquely identify, record, or row in a table. There are several kinds of Ks in a table. The first is super K. Super K is one or more attributes or columns that can uniquely identify each row in a table. The second is candidate K. Candidate K is a minimal set of attributes that can be used as identities to uniquely identify each record in a table. Next is primary key. Primary key is the most unique attributes from the candidate key that can be used to distinguish between an entity member to another entity member. Then the alternate key. The alternate key is candidate key that is not selected as the primary key. Next is the composite key. Key that be composed of two or more attributes. If the attribute stands alone, cannot identify a record, but when combined, it can identify uniquely. This is called a composite key. Foreign key is attribute with the same domain. This attribute becomes the primary key in a table, but in other tables, this attribute is an only simple attribute. For example, you can see in this student table, this table consists of many attributes, that is student ID, citizen ID card, name, birthplace, birth date, and address. From the student table, the attributes that can be super K are student ID, citizen ID card, name, birth date, and address. Furthermore, from the super K, we can select candidate K. The candidate key from this table are student ID, citizen ID card, and name. From several candidate keys, the most unique key will be selected, and it can distinguish an entity from other entities. This key is called primary key. We need to select the primary key of an entity to make us easier when processing the data. Previously, we got the candidate keys from the student table are student ID, citizen ID card, and name. For example, if we are going to use this table for academic purpose, we have to choose one of the most unique attributes among the three existing attributes to be the primary key. The name attribute is not unique because there might be two students who have identical name. And then the citizen ID card attribute is unique because every citizen has an identical citizen ID card. But it could be that students don't have a citizen card because they were not 70 years old when they were in college. So the student ID attribute is unique, and each student who has been enrolled in college must have student ID. So we can use student ID as the primary key. Therefore, citizen ID card and name will be an alternate key. Next, I will explain an example related to foreign key. As explained before, each entity in the database must have a relationship with another entity. Therefore, an entity that has relationship with another entity must contain the foreign key of the entity that is related to it. Foreign key is an attribute that becomes the primary key in a table, but in other tables, this attribute is only a simple attribute. Okay, for example, if we have a student table with the attributes are student ID, citizen ID card, name, birthplace, birth date, and address. And we have the course table with attributes are course code, course name, credits, and semester. Student table and course table have a primary key. Student ID is the primary key of student table, and course code is the primary key of the course table. For example, student and course entities have relationship with core entity that contains information related to student score in a particular course. To connect these three entities, we can use student ID and course code in the score entity as the foreign keys. So the student ID is primary key in student table, but this student ID is foreign key in core table. And the last, I will explain an example related to composite key. Composite key is key that be composed of two or more attributes. And if the attributes stand alone, cannot identify a record, but when combined, it can identify uniquely. For example, in the student table, the name attribute is composed of first name and last name. Suppose that each student has unique name. We can use a combination of these two attributes to uniquely identify each student. Because the key that used consists of two or more attributes and can be uniquely identified, these first name and last name are referred to as a composite key. Next, we will discuss about the entity relationship diagram, or we can call it ERD. ERD is a diagram used to create a model which explains the relationship between entities in a database with certain graphic symbol. There are various components in the ERD that are represented by certain graphic symbol. The first is a rectangle that represents the entity, and then a double rectangle represents a weak entity. The entity is divided into two types that are strong entity and weak entity. Strong entity is an entity that has primary key. Meanwhile, the weak entity is an entity that does not have a primary key. Weak entity is an entity which depends on the existence of another entity. Weak entity must be determined by the relationship of the foreign key to another entity. This is because the weak entity cannot be uniquely identified by its own attributes. For example, a room can only exist in a building. So the room entity is a weak entity because it cannot exist without the building entity. The next is the ascript symbol. It represents a simple attribute, which is an attribute that has a single value and cannot be decomposed into more specific attribute. Then the ellipse with an underscore is an attribute that has becomes the primary key that can uniquely distinguish an entity. And then the dash ellipse, it represents a derived attribute that is an attribute that derived from another attribute. For example, the age attribute, its value can be derived from birth date by finding the difference between birth date and current date. Then the double ellipse represents the multi-valued attribute, which is an attribute that can have more than one value. For example, a student can have several hobbies, or a student can have several phone numbers. The last one is a composite attribute, which is an attribute that can be divided into smaller attributes. For example, the name attribute can be divided into first name, middle name, and last name. The next symbol is a line that represents the link between the attributes of an entity. And then the diamond represents the relationship between two entities. Furthermore, I will explain about participant constraint of an entity in a relationship. Participant constraints are divided into two, that are total participants and partial participants. The total participant is represented by double lens, which explains that all entities are involved in the relationship. Meanwhile, a single lens is used to represent partial participant, which explains that not all entities are involved in the relationship. Next, I will explain the concept related to cardinality and ordinality in ERD. Cardinality specifies the maximum number of instances from an entity that has relationship with instances from other entities. And ordinality specifies the minimum number of instances from an entity that has relationship with instances from other entities. So cardinality specifies the maximum and ordinality specifies the minimum. There are several styles that can be used to describe the cardinality and ordinality of ERD. The first is information engineering style. The information engineering style can be seen in this picture. So you can see the relationship is described using symbol. For example, in this picture is one-to-one, one-to-many, many, one or more, one and only one, zero or one, and zero or many. We can use these symbols depends on our case. And the second is the chain style. You can see chain style in this image. The ordinality and cardinality is described using number 0, 1, or n. Ordinality describes the minimum and cardinality describes the maximum. And the third style is Bahman style. The Bahman style can be seen in this picture. The Bahman style is described using a symbol. For example, in this picture is 1-to-1, 0 or more to 1 or more, and 1-to-1 or more. And the last style is Martin style. You can see the Martin style in this picture. This style is almost same with the chain style. We use 0, 1, or n to describe the ordinality and cardinality from ERD. You can use any style to describe about your ordinality and cardinality in entity relationship diagram. It depends on what is the style that you choose. So it depends on you. You can choose any of the style to describe in ERD. Okay, the last, we will discuss a case study of how to make an entity relationship diagram. This is the example of how to make entity relationship diagram from a study case. At every airport already have schedules for all airlines flying both domestic and international flights, where the airport had to reschedule to the aircraft and flight service both departures and arrivals. Officer to manage the air traffic is commonly called air traffic controllers or ATC. And ATC has an important role, especially on the aircraft, to prevent an aircraft is not too close to each other, to prevent collision between aircraft and aircraft with obstacle in the vicinity during operation. Additionally, ATC has a role in regulating the smooth flow of traffic, helping the pilot in control of a state of emergency, giving the information needed pilots, such as weather information, flight navigation information, and air traffic information. ATC is the closest associates during a pilot in the air, and ATC has a role in the achievement of the flight. So in flight service system has several services offered via the website, including the following. First, the airport can see the current weather situation, good or bad, to do the flight. Flag status, for example landing, takeoff delay, and arrivals, flight, and flight destination. And the second, they can see the task schedule for flights from and to where, who, the pilots, flight attendants, and the crew. The third is, again can sell book, view price of planes, and flight schedule. And the last, customer can see flight schedule, flight route, see ticket price, and book ticket. This image shows you an example of an entity relationship diagram based on case that previously described. It can be seen here that airlines have planes and aircraft or planes is scheduled by airport. And then the airport has tower, and you can see in here airline have crews, and the crew can see the information about weather. The weather information also can be accessed by the tower. And then you can see in here for customer, it can be see that customer can do reservation to the agent and customer can reserve the seat. And customer also can reserve in a new entity inside this rectangle that contain combination of airline, aircraft, and airport entity and its relationship. This new entity called aggregation entity. That is an entity that contains relationship between two or more entities. So the combination of airline, aircraft, and airport become a new entity. You can see in here there is another aggregation entity. We can see that the crew can see the crew schedule, which includes information from all entities inside this rectangle that contains several entities such as for airline, then aircraft and airport, and then customer and chair and again. You can see in here that 1 and n tell you about the ordinality and cardinality of this ERD. I think enough our discussion regarding entity relationship diagram. Thank you for watching and see you on the next video.